Okay, in this video we are going to explain how alternating current can be used with an electromagnet to create a vibration. So let's just review what we know about current and magnetic fields. So first of all, if you have a wire and there's current moving through that wire, electrons flowing, the direction of the magnetic field is in circles around it. So your right hand rule can help you determine the direction. Your thumb points in the direction of the current, and your fingers wrap around in the direction of the magnetic field. Here's the simple B. So here I have two electromagnets. So the electromagnet is just using electricity to produce magnetism. So whenever you have current in a wire, this occurs. So let's say this is my positive end of my battery, my negative end of my battery. And let's assume that the current is moving in this direction. Okay, so the current is moving up here. Let's follow along. It wraps around the back of the wire, and at this point it's going to be coming towards us. So we show coming towards us with a dot. So you can remember, if you're having trouble remembering, think of an arrow. Right? If you see that arrow coming towards you, you're going to picture the dot. Whereas if you shoot an arrow going away from you, you're going to see an X. So here the current is moving towards you like the tip of an arrow, and now it's moving away from you like the tail of an arrow. And again, towards you, away from you, and then this will continue down the entire length of the solenoid. Now, remember, the concept is current in a wire produces a magnetic field. So we got to figure out what's the direction of this magnetic field that's created. So you might be able to figure it out without doing this, but if you use your right hand rule and have your thumb pointing towards you at this location, your fingers will wrap around in this direction. Whereas here the current is moving away from you, use your right hand rule and the magnetic field lines point in that direction. Now if you're having trouble with this, I made a video called Electromagnets, which will help explain in more detail. But inside of this solenoid, or inside of this electromagnet, we see the magnetic field points in this direction. So, and outside the magnetic field points in these directions. So the magnetic field that's going to be created from the solenoid would be around like this. Now, just remember, if I have a bar magnet, and a bar magnet, the magnetic field lines come out of the north. So this would be like the north end, and this would be the south end. Now, if I were somehow to take that battery and flip it around so that I now have positive end over here and my negative end on the other side, if we follow the direction of the current, we'll say it moves this way and then down and away. So I'm going to have an X here, and it's going to curl up towards my finger. I have a dot here, X, dot, and so forth. We can draw the magnetic field lines that would be around that. So the magnetic field would point in this direction, and with my X, would point in that direction. And the magnetic field that would be from the entire solenoid would be in this direction inside and this direction outside. So here, remember, magnetic field lines come out of the north, so this is the north end of my electromagnet, this is the south end. So the whole key I'm trying to get across here is if you change the direction of the current, this changes the direction in the magnetic field. This went from a north to a south just by changing the direction of the current. So what we can do is we can put a small magnet over here. And let's just make this my north end and this is my south end. And put that exact same magnet right here. Now, north and north, these two are going to repel from one another. They're going to push away and repel. Whereas here I have a south and a north. These two are going to... Okay, so these two are going to attract. So, in your speaker, what you have set up is you have an electromagnet and you have a small permanent magnet. And when you have the direction of the current moving one way, let's just say that gives you a south and a north end. So the current is going to create a magnetic field similar to here, and that magnetic field is going to either have a south end or a north end, one of it. So here it has a south end, I've got another south end here, these two are going to repel. Then all of a sudden, your speaker changes the direction of the current. So now instead of the current moving down here, it move up. So as soon as you change the direction of the current, this changes the direction of the magnetic field. So the magnetic field goes from a south to all of a sudden now it's a north. And this went from repelling to now I have north-south attract. And then a moment later, a split second later, it reverses once again. The current points down at this location. This goes from a north to a south. This goes back to north. And it goes from attracting to again repelling. So if you do this a number of times per second and attach this system to, this is the cone of your speaker, what it can create is, well, this cone is either being repelled or it's being attracted, and then it's being repelled and then it's being retracted. So this causes a vibration. I mean, we could think of this as the cone that's being either repelled or attracted. It's vibrating back and forth. When you have a vibration, then, and as long as you have a medium, you can sound can be produced, creating areas of high pressure compressions or low pressure rarefactions. So the last question is, how do they get this current to change from down to up so many times? If you remember from our last video, we learned a little bit about alternating current. So alternating current, if you change the direction of the current, again, that changes the direction of the magnetic field. That's the concept we just went over. So really what's happening in your speaker is it's changing the direction of the current so many times per second. And this is how alternating current is produced. We'll talk about this in a future class. But depending on the note that you want to play on your iPod, it'll change the direction of the current back and forth so many times per second. And if you change the direction of the current more times per second, that would create a higher frequency, and less times per second, that would create a lower frequency. So that's all for now. Hopefully you've learned to explain how alternating current can be used with an electromagnet to create a vibration.